Welcome to This Explainer. Today, we're jumping right into a highly immersive digital tour to see exactly how Industry 4.0 is completely redefining the physical world around us, creating these hyper-efficient, almost magical workspaces. You know, we talk about the digital economy all the time, like it's just something floating up there in the cloud. But the reality? The reality is that these advanced technologies are being directly embedded into the concrete, glass, and steel of our cities. Let's get right into it.
Take a look at this absolutely stunning exterior. This is Deloitte's Amsterdam office, widely known as the Edge. Back in 2015, Bloomberg hailed this structure as one of the smartest buildings and most connected offices on the entire planet. And here is the most astonishing fact right out of the gate. This massive, highly connected commercial building actually generates more electricity than it consumes. It's a net positive energy producer. I mean, that completely flips our traditional understanding of what an office building does to the environment.
So, you're probably wondering, what's the secret behind this unprecedented surplus of power? Well, it all boils down to one crucial, massive number: 28,000. How does a colossal glass structure become so intelligent and so efficient that it literally generates its own power? It all comes down to what that number actually represents.
That 28,000 represents the sheer volume of tiny, highly sensitive sensors packed into this single building. Think of these sensors as an active, living nervous system for the structure. They're constantly, silently gathering real-time data from the physical environment around them. They detect motion to track occupancy patterns, they dynamically measure ambient light, pinpoint temperature drops, track humidity, and closely monitor the exact carbon dioxide levels in the air. Basically, the building constantly knows exactly what's happening in every single corner of its physical space.
But here is where it gets incredibly cool. This intelligence isn't just locked away in some basement for building managers, it's placed directly into the hands of the workers. Using a smartphone app, employees connect instantly to the building's systems. Right where they sit, they can personally manage the light levels, adjust the temperature, and handle their daily logistics. The app even knows your schedule, directs you to an available desk suited to your agenda, and, get this, it even knows how you like your coffee. The building responds to individual needs in real time, creating a wildly specific microclimate for every single worker.
Now, all of that data from those 28,000 sensors doesn't just disappear into the ether. It feeds directly into a complex central data dashboard. This acts as the active brain processing the chaos. Every physical action, from a room filling up with people to a sudden spike in humidity, is monitored, visualized, and turned into actionable digital insights. This dashboard is what allows the building managers to understand the real-time flow of resources and occupancy, ensuring that absolutely no energy is ever wasted on heating or lighting an empty space. We're all likely very familiar with the Internet of Things, or IoT. But here, IoT is taken to its absolute limit. It acts as the ultimate bridge between the physical room and the digital dashboard. By gathering and relaying data from the environment, IoT provides the essential connectivity and active feedback loops needed to fuel big data analytics on a massive scale. It transforms everyday architectural elements into highly intelligent assets.
And when you infuse those IoT devices with integrated computation, processing, and networking capabilities, you get cyber-physical systems, or CPS. For those following Industry 4.0, you know this is where the magic really happens. CPS links machines, devices, and the physical space directly to digital services. It's an evolutionary step. It's not just about collecting data anymore, it's about enhanced autonomous decision-making based on that real-time flow of information. So this isn't merely a building with some fancy sensors. It is a fully realized, living cyber-physical system.
The ultimate result of combining IoT and cyber-physical systems is the creation of dynamic feedback loops. By constantly circulating data across connected systems, these technologies monitor an asset, analyze its performance, and immediately adjust its operation. These loops allow us to dramatically better manage our real-world resources. For example, if the CO2 levels rise in a meeting room, the feedback loop instantly triggers the ventilation system. If a corridor empties out, the loop dims the lights. The physical environment is constantly optimizing itself entirely without human intervention. Now, let's zoom out from just this one remarkable office in Amsterdam and think about the broader implications. Applying these intelligent assets globally leads to massive, systemic changes. When we use data to drive our infrastructure, we see optimized resource allocation for maintenance, significantly reduced technical downtime of systems, incredible drops in energy consumption, and slashed waste and pollution.
This is exactly how we begin to tackle massive environmental challenges, by making our physical world as astoundingly smart and efficient as our digital one.
Experts in Industry 4.0 note that this technology stack isn't just about having a cool, futuristic office to show off. It is the very blueprint for a digitally empowered circular economy. By radically reducing defects, waste, emissions, and energy consumption, technologies like IoT and cyber-physical systems become absolutely vital tools for achieving global sustainable development goals. They definitively prove that economic competitiveness and environmental sustainability can actually go hand in hand.
So, we want to leave you with this to ponder. If one single building in Amsterdam can generate its own power, manage its own climate down to the individual desk, and drastically cut its environmental footprint using 28,000 data points, how might these cyber-physical systems transform the spaces you live and work in every single day? Imagine your entire city operating as one massive, perfectly optimized feedback loop. The technology is already here. It's really just a matter of where we decide to build the next edge.